I've napped in a Waymo. You know what I mean? It's just so comfortable and 100% trust. It just works. And I honestly trust it more than a human, frankly, at this point.
Oh, I trust it way more than a human. I've been in an Uber as it's gotten into a car crash.
Oh my God. Yeah. Right?
Yeah.
Yeah.
Speaking patterns break the code, pre-trained pod.
Welcome back to the Pre-Trained Pod, where AI scientists talk shop and talk shit. My name is Richard. I'm an AI research fellow at the University of Cambridge. With me, as always, is the one and only Pierce Freeman.
Hey everyone, I'm Pierce. I am a AI founder based in San Francisco, and I've built and sold multiple startups.
I was going to say the one and only, the inimitable Pierce, but I feel like saying inimitable is kind of a hard word. You know, you kind of have to like slur that to get it right.
It's a good SAT word, though.
It is truly, yeah. The inimitable Pierce.
The inevitable, the unduplicatable.
The unduplicatable, the one and only. Pierce, today we're talking cars, baby. And we're going to talk about Waymo.
That's our kind of car. You know, Richard, I got to tell you, I feel like us nerds cannot hold a conversation about any other type of car. Like, you want to talk to me about pistons, oil changes, really can't help you. Self-driving cars and lidar arrays, that's our bread and butter.
That's our bread and butter, dude. Dude, Waymo is so cool.
It's so coded.
It's so good, dude. Look, man, there's a lot of people that I've talked to here in London that whenever I describe to them the Waymo experience, their reaction is, oh, really? We can do that already? I think people are aware of Waymo, like they've heard of Waymo, or whatever country-specific version of Waymo is being developed in their place. So like in England, everyone's talking about Wave, which is kind of like the British Waymo.
But you guys don't have any publicly available driving, right? Like, you can't just hail a Wave, can you?
So you'll like occasionally see a self-driving vehicle, but it's kind of like, you know how SF was in like 2019, 2020, where you would see these cars and you would understand that they're collecting data right now.
Yeah. And there's a human in the driver's seat.
And there's a human in there.
Yeah.
And most importantly, you understand that this isn't a product that you can actually use, right? It's very much like at some point in the future, I understand that we'll be using these self-driving cars. This just isn't something that I can do now. People don't understand that in SF, this has been a reality for the last 2 years or so, roughly 2.5 maybe at this point.
Yeah.
Let me paint the scene here for all of our UK listeners and folks that haven't gone out to the States and used one of these products. The future is here, guys. Like, when I was in San Francisco, I remember downloading the Waymo app and seeing that car just pull up autonomously, flash its like little blue lights or whatever, and the door opens. It's such a magical experience. Like, it's honestly hard to describe how eerie it is, how futuristic it is, from like the user experience of calling the cab, the Waymo, to getting in, to actually starting the ride.
The voice greeting you.
The
when you
voice
get in the
greeting
car,
you.
It says, "Hello, Richard.
Yeah,
Hope
like
you're having a nice day."
Exactly. You enter this car, you see your name, right? So you see Richard on a big screen that's only for passengers. Only passengers can see the screen. It basically says, you know, buckle in. It describes the experience. And then there's a big button that says start ride or something like that. You press that button, and all of a sudden the car slowly pulls out and you're just on the road with literally no one in the driver's seat. It's just this eerie ass experience.
And you see the steering wheel turning. I feel like that's also part of the cars too. It's like they're retrofitted Jaguars, just with all the sensors and everything else. But the steering wheel is still there, and it also turns. So it's almost as if there's a ghost driving this thing.
It's so eerie, dog. And the craziest thing about it is that you get used to it within 5 minutes. You would think for the first time when you get in that this is going to be the scariest thing you could ever possibly do. But honestly, dog, it feels so safe, just natural almost. It just blew my mind as a passenger how quickly you can get used to really frontier technology. It was almost like one of these ChatGPT moments for me where, you know, when chat first came out, you were shocked that it could do this. But then within a couple minutes, you start playing around with it. And then it kind of felt like, oh, I get it now. You know, this is now a tool that I have access to, and my life has changed. I'm never not going to use this from now on. That was my experience with Waymo when I got into one like a year and a half ago for the first time. It's truly like game changing. It's like day or night. And since being back here in London, not having access to it, I am so excited to be able to go back to the States and exclusively use Waymo going forward, just because the experience is just so pleasant.
Yeah.
I'm such a stan, dude.
It's objectively better.
Here's my first question to you, Doug. When you got into your first Waymo, put yourself back in that position, what surprised you the most?
Oh man, the earliest possible that you could get off the wait list as a non-Google affiliated employee was 2023, I think. And I was the first one out of the gate. I really wanted to try these things because we'd be seeing them for so long,
Yeah.
And I also knew people who were at Waymo and at Google who'd been telling me about them and said, this is the real deal. It was after we had been promised self-driving cars for years, like Elon was pounding the pavement as early as 2017 about self-driving cars. And I was like, they're finally going to be here. And then nothing. And then 2023, they finally opened up this wait list. So I signed up for both Waymo and Cruise because Cruise used to be this independent company, got bought by GM. I think at that point was operating under the GM umbrella. So like Cruise were these kind of buggy looking cars. The Waymos are just these converted F-Pace Jaguars, which let me tell you, are a lot nicer. But I did them.
They're nice cars, dude.
They're nice cars. And I got off the wait list within maybe 2 days of one another. So I was like, okay, I'm seeing some friends, other side of the city. I was in the marina and I was trying to get to the sunset or something. So I'm with some friends, call the car. They are spooked. I'm ready for this. I'm excited. They're trepidatious.
You're pumped.
I'm really stoked because I will say at this point, it is so normalized that even if you have not ridden in a Waymo before, so many people who have that you trust their experience of being safe in the cars. We were going in blind. None of us had ever ridden in a self-driving car before. And I'll tell you, for the most part, it was what you said. You're sitting in there, you're taking videos, you're amazed. It's all that you can talk about. And then within 5 minutes, you kind of get used to it. You're like, okay, this just works pretty well. In the early days, though, the edge cases still were not totally hammered out. Like it kind of felt like their generalization performance wasn't quite there yet, or they were being overly cautious. So if another car got within even a couple feet of the Waymo would just slam on the brakes.
Oh,
and in
okay.
San Francisco, people drive kind of aggressively. It's no New York City, but it's also no suburbs in Kansas. So that would sometimes happen. Waymo would just aggressively brake. You're thrown forward. No human would have done that in the same situation. I also remember Cruise took turns way too quickly. The Waymo was better, but Cruise would not slow down or break into a turn. So it felt like you were just taking a pretty aggressive curve, like off of Market at 35 miles an hour. And I was just being whipped to the side. Again, very unhuman.
It's because you drive like a grandma, dude.
I know, dude. Everyone listening is like, that's exactly how I drive. What are you
what are you talking about, dude?
I almost failed my DMV exam when I first got my permit, or got the license after the permit, because I was driving so slowly that this instructor was like, you really can drive faster. It's okay, I'm not going to flunk you. And I just looked at them and I was like, this is genuinely how fast I drive. This isn't a show. This is just how fast I drive. So anyway, we did these rides. It was like a good organic A/B test. The consensus among this group of people was that Waymos were just better. It was like a smoother ride, nicer cars. It seemed like the AI was more sophisticated. I knew at that point that I was a full convert, but I was like, let's give this a couple years. Let's like really see how this shakes out. And I'd say within 6 months, all those problems totally addressed. The rapid pace of progress was just absolutely astounding from getting into these during the beta to when they actually went public. They hammered out all of those problems. And I love them, dude. I'll at least check a Waymo first by default every time. And my threshold is if it can get here within 10 minutes, and if it's not more than 1.5 times as expensive as an Uber, I'll do Waymo.
100%. And the nice thing about Waymos too is that at night, there's so many of them because they're just patrolling the streets. It's not like an Uber driver where they go home at 1 a.m. If you want to call like a Waymo at 3 a.m. to go to the airport, it's going to be so easy. You're going to get one within like 2 minutes.
Yeah.
It just changes how you think about getting places where it's like, oh, actually in the middle of the night, it's when you're going to get somewhere the fastest because you're easily going to get a Waymo. The other thing about Waymo is that for me, it's fundamentally changed how I think about getting in a car or going from point A to point B. Before, it kind of felt like when you get an Uber or when you drive somewhere, you're just like in this in-between space where you can't really do work. You can't really talk to someone. Like, you don't really want to get on the phone. It's kind of rude, right, to the Uber driver.
Mhm.
You're not by yourself, but you're kind of by yourself. So you're just on your phone, probably scrolling something, or like you're trying to read something, or you're making some like bad small talk. Getting in a Waymo for me for the first time just blew my mind because it's this new third space that opens up, right? Where let's say point A is 30 minutes away from point B, right? You're going across the city. Those 30 minutes now, you can use it for like a private phone call. You can use it to like do a little bit more work. You can use it to like truly be by yourself, which is weirdly enough like a very relaxing experience. It's like that feeling of coming home from work and just dropping down on the couch or on the bed. And it's like, oh, dude, finally. You know what I mean? I can just like vibe for a little bit. It's that feeling. It's like this fundamental rethink of the commuter experience as being something pleasurable, something you look forward to. And for the first time ever, I really understood why, when you have full autonomous vehicles, you should just fundamentally redesign and rethink the car. Because now it makes so much sense to all of a sudden, rather than having, seats facing forward, have a desk there, do some work, right? Or make it really easy to like have some food in the car. Make it so that if you have a friend in there, you're like facing each other rather than all facing forward direction. Like
Yeah, you're trying to make it a lounge or a
it's a
co-working
lounge. Yeah,
space. You're
exactly.
trying to turn it into something else, and you can. It's just on wheels because you don't have to deal with these constraints of what I think made a lot of sense when we had to drive cars where everyone would face in the same direction. I think you also hit on something there latently, which is why I love Waymos, and I actually think in some ways Uber can't compete. Uber laid the groundwork for, I think, what is so nice about Waymos, which is being able to drop a pin of where you are and where you're going to. And I think what was really clever about Waymos, maybe what's obvious in hindsight, is that they just copied that exact same contract. The app looks the same as Uber does. You just put in the location that you're trying to go, it defaults to your current pin, and then you click call ride. There's literally zero adjustment to like a new user interface paradigm. And the other thing that I think is crazy is you just know what you're going to get. With Uber, I didn't really realize this until Waymos, but sometimes when you're in an Uber, the driver wants to talk.
Yeah.
Sometimes they don't. Sometimes they drive really quickly. Sometimes they drive slowly. Sometimes the car is brand new. Sometimes it's really old. Like you're almost pulling from some like underlying distribution every time you call an Uber, and you have no idea the confines of what the next 30 minutes is going to look like. You just have to get in the car and see, and then respond accordingly. Whereas your ability to plan with Waymos, you know the quality of the car is going to be high. It's the same exact model of car from car to car. And you know that there's not going to be anyone there. So you don't have to deal with this, tertiary factor of how does that other person want you to interact with the
Yeah.
space.
Yeah.
You can plan. You have full complete control. And honestly, that consistency is never something that I would have focus grouped to say I'm looking for this in a driving experience when I'm ride hailing. But once you have it, is an absolutely game changing
Amazing.
shift.
Yeah.
Yeah, it's just
Absolutely.
it transforms the space. You're right.
And for me also, I feel a little stress when I have to find the Uber. There's some understanding of like, hey, this person's either waiting on me or I can't find them. And I want to make sure that they like know where I am or that they're not going to be looking for me. With a Waymo, it just pulls up. I don't care if it waits like a minute for me. You just get a notification, hey, it's here. I'll just stroll out, get in it, and then just go. It kind of it makes the experience of going out the door into another vehicle seamless. And that experience is also just like magical. Something about that just feels so fundamentally pleasurable from just going from point A to point B. It almost feels like you're just being teleported across, right? Without any like mental effort really going into this interaction. So is it safe to say that you just don't really use Uber anymore if you don't have to?
Yeah, if it's within 1.5x of an Uber price, and if it can get here within 10 minutes, I will always call Waymo. Can I maybe add one more thing here too?
Sure.
Which I think is the immediate response of people that are outside of the Bay is one, how do you possibly trust these things? Right. And two, won't this replace people's jobs? I have talked to so many Uber drivers about this. They've brought it up. I've asked them whatever. They all seem pretty chill with it, honestly. And maybe that's just like the San Francisco mindset talking, but all these people's attitude is kind of like, look, if I don't end up driving for Uber, I'll just go do something else. They seem like very flexible and like open to just doing other things. Uber happens to be what they do because they can make a relatively good stream of income doing it. But all the people that I've talked to do not feel personally passionate about driving for Uber. And some were like, honestly, I'm thinking about leaving this and just helping Waymo train their cars.
Oh, interesting.
It's
Huh.
just like label data for them, do it at home,
Yep.
stay in your sweatpants.
Mhm.
Like, I think at this point, honestly, driving for Uber is like a pretty like bad gig, or worse than it's been, because you don't get that much money. Like, Uber takes such a premium on top of your fares. You have to pay all the underlying expenses of like the car, the maintenance, the insurance, whatever. The people that would be most affected by this seem chiller than I would expect to be about the transition to autonomy. And I just found that interesting.
I saw this funny tweet. I don't know if it's true or not. I think it's satirical, but it might be true. Where someone was commenting on the fact that as a parent in San Francisco, it's so nice to have a Waymo so that you can shuttle your kid,
Yeah.
your newborn, from point A to point B. And they don't know how they would do it otherwise if it weren't for Waymo. So you can just put in your 6-month-old in this Waymo and then send them to your partner to take care of your kid, you know?
I think this is legit, dude.
It might be legit, but the point is that people super trust it. I think that that is actually so important to underscore. I've napped in a Waymo. You know what I mean? It's just so comfortable and 100% trust. It just works. It's magical. And I honestly trust it more than a human, frankly, at this point.
Oh, I trust it way more than a human. I've been in an Uber as it's gotten into a car crash.
Oh my God. Yeah.
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 I won't rehash that on the pod, but like, I have seen what happens when people don't pay attention. And look, it was at a four-way stop. I don't really think my Uber driver was at fault. I think it was mostly this woman that ended up T-boning him. But still, I actually don't care whose fault it was. I am absolutely convinced that a Waymo would not have ended up in that same spot. Like, I think a Waymo either would have accelerated out of the way or would have braked way earlier. They're better,
They
Like,
just are. Yeah. They
at
really
the end
are.
of the day, you need, when something goes bad, usually things don't, but when something goes bad, you need your reaction time and then the actions you take to be so fast that you're guaranteed to have that processing speed and latency with a computer in a way that you're just not with a human. Maybe some humans can do it. Maybe you get lucky, but like, the statistics don't lie. Waymos at this point are way safer per mile driven than humans are.
It's cool to see a LM based model have superhuman performance at something and then display that in the physical world. I think that you rarely see that. Obviously, computers have had superhuman performance on many things for decades now. And robots are also superhuman in a lot of ways. But I don't know of a good use case of an intelligent system that uses AI in the physical world have superhuman performance
Yeah.
other than Waymo. Like, Waymo is the first time where I was really like, oh, this is for something to do something better than a human that isn't a human, but that still requires super complicated reasoning. Maybe that's why Waymo just feels so magical,
Yeah, I think they also do something that we can relate to. Everyone drives. And I think
Yep.
we know that there are so many edge cases and the complexities. I'll tell you that to a T, you do not pass a tourist group in San Francisco when you're in a Waymo without them smiling at the Waymo. There is this
100%.
like a genuine sense of awe, amazement, like unbridled childlike joy when people see these cars that I don't think people get elsewhere. Like, I don't think people, when they're interacting with chat for the first time, are grinning from ear to ear, because it's kind of like, well, this fits in the same paradigm as just text messaging your really knowledgeable buddy.
Yep.
It's faster. I know AI is doing this, but like, driving fully, there's no one in the passenger seat. It's so out of distribution. You almost think this should be magic. And I'll also say, like, I think Waymo is ahead of the pack. I would be just as passionate about any frontier autonomy company. This isn't necessarily like a Waymo specific phenomenon. I think all our points that we're raising here are true just of this space, not necessarily true of Waymo. And I think it's very interesting that now Waymo is just so tied to being the top dog here. It's kind of like Google with search. We're just,
Yeah.
if you're going to search something, you say,
You're going to use Google.
I'm going to
honestly.
Google
Yeah.
it. And if you want to call an autonomous car, you say, let's call a Waymo. They have just owned this mental model.
Absolutely. I mean, honestly, Pierce, I think we wrap the show here. We love Waymo. This is the, no, I'm kidding. Okay. We've been fangirling over
Too
Waymo
much.
now
We
for
can't
the
go over them too much.
last 30 minutes. Let's get into it, man. Run me through how you think the system used to work. What's so special about Waymo? Give me like an overarching overview. How the hell does it work?
I think maybe let's drill down based on what we can actually see to what we suspect. You can see the sensors that are on the car. So there's a combination of regular cameras. So the same camera that is recording this podcast, join us on YouTube. They have radar systems, they have lidar systems, they have some microphones outside the car as well, so they can detect sirens that are in the distance. They have all of these different multimodal sensors because they each tell you something different about the world, right? I think we all can kind of understand what a regular RGB camera does. It captures light, puts it on digital sensor, converts that to an image. That seems pretty obvious. Radar, I think people also kind of can understand what that is from, radar towers and from all the Cold War movies that people would watch. LiDAR is probably the most unique of the bunch and really has found a primary deployment within self-driving cars. And it works by spinning around and then throwing really rapid fire lasers at the scenery around it and then measuring the bounce back, right? So it's kind of like radar in principle, which is why the names are similar, but it's using light, it's using optics to do that registration. And what you get as the output of this system, regardless of the physics of how it works, is a point cloud where you can see how far away different things are. So if you squint, you can kind of say, oh, this looks like a building. But that's not really the idea. It's basically saying, we're just trying to get a mapping of the different physical objects that are going to be close to you and far away from you and use that depth sensing in order to feed into a system that really requires knowledge of depth to know where are things around this so it doesn't hit anything.
Mm-hmm.
So those are the sensors that are on the outside. And then internally that feeds in to maybe like 2 or 3 GPUs. There's pretty serious processing power that's located right within the Waymo's trunk because it all has to happen on device.
Right.
As far as they've said, nothing happens in cloud processing on the Waymos, including when people call support and they can see the car and see what's going on. As far as I know, not even they can override what the Waymos choose. It all happens on site, on the edge. So the computational processing, which I feel like we'll do deep dive into in a second, is basically saying, let's take all of these different LiDAR systems, cameras, let's combine them, let's try to figure out what's happening around us. And then based upon that signal, let's use a combination of some rules that should always be followed. If there's a stop sign, we always have to stop. That should probably be some deterministic decision function. And then combine it with some more statistical modeling of how driving works. How can we drive to be a little bit more human? And then once we have these predictions of the next course that the Waymo should take, we then feed that into a control system that turns the steering wheel, changes the speed, that kind of thing. That part is just a conventional control system that's been solved in cars for a really long time. The bread and butter of what makes Waymo so different is really this perception system in the computational processing and then all of the sensors that they have scattered around the car.
Can we maybe back up just 1 second and contrast this to what's going on in a Tesla? Because people will say, hey, a Tesla is autonomous as well. I think what's so unique about the Waymo is that it's the first, what we would call level 4, I believe, automation system. So there's like the scale from 0 to 5 that measures how autonomous is a vehicle. Level 0 is literally not autonomous at all. Level 5 is ultimate autonomy. So I, in San Francisco, get in my vehicle and I'm like, hey, I want to drive to Yellowstone. Okay, I want to pull up to that lodge in the middle of the woods. Thanks for driving me. I'm just going to be back here napping, basically, right? And it just does the whole thing for you. This here is a level 4 autonomous system, which basically means that napping is technically allowed. Like you can take a nap, like the system will take over, but it's kind of conditional on some sort of parameters. So in Waymo's case, it does this full autonomy, but only in a geofenced region. It can do the thing where you just give it a point, it does the driving for you, but it can't go to LA for you. It can't drive to Yellowstone for you, right? It can't really go off-piste, off-terrain, drive through the woods. Can't do that now, right?
Before this week, it also couldn't even go on freeways, right?
It couldn't even go on freeways, right? So it was really
I think it topped out
geofenced.
speed at 35, 40 miles an hour.
Teslas are, I think people call it level 2.5. So level 3 is this conditional driving automation where the driver can be a passenger, but at any point in time has to be able to take over. Level 2 is basically advanced cruise control, where the car can do steering, braking, accelerating for you, but you still have to do a little bit of like the steering occasionally, right? So Teslas are in this in between zone. Maybe they're approaching level 3 pretty soon, but you still have to be very much at the ready. You can't just be napping in a Tesla. That is to say, Waymos, in part because of all this advanced lidar system, in part because of all this advanced computation, and in this geofenced region, they're really the first system that can achieve level 4 autonomy.
And I think what we were saying before, which is like Waymo's ahead of the pack, they're ahead of the pack because they're really the only option that is on commercial roads in the US that is at level 4, and they're inching closer to level 5.
It's almost like we're tackling level 5 autonomy from these two different angles, where Waymo is saying we're going to do full autonomy, but in a geo-controlled region, and we're slowly going to expand that out so that this year, for the first time, you can go on freeways. You can go from SF to San Jose, like a 1.5 hour drive, all in this autonomous zone where within this zone, we've achieved level 5, and we're slowly going to expand the bounds of that region. Teslas, obviously, you can drive them anywhere, but they already start with this global zone, but they don't have the full autonomy. So like they're inching towards better and better algorithms that can get us to level 5. It's almost like this two-pronged approach, and we'll have to see which one wins in the long run.
Yeah, that's interesting. I mean, I think, the Tesla stands who are very bullish about their self-driving capabilities for a long time have been saying that Tesla's just going to win on the data. I mean, they have so many cars driving. Every Tesla that's on the road right now is equipped with the camera system and the radar system that you would need for self-driving. It's a software-enabled feature, right? So every car has the hardware. They just don't really have the software, which means that in theory, Tesla can capture data on cars even outside of the self-driving car program. Like maybe you don't pay for it, but you can capture the data, you can upload it to some central computing. So they've effectively outsourced, instead of having to go to a scale AI, they've outsourced the creation and maybe some of the labeling of this data as well, because they actually have people that are driving in these situations. It's very smart if I'm just trying to whiteboard this of, wow, they're capturing such diverse data. They're seeing Teslas in so many different situations that you would want as part of a really generalized paradigm. And yet, right now, Waymo is still so far ahead, at least in the regions where they're geofenced. I will be interested to see where we end up converging and who hits that first. I feel like one of the things that separates Teslas from Waymos as well is the fact that the sensors that are on the different cars are pretty profoundly different. Tesla needed to get them to a price point where they could bundle them with every car. Waymo is purpose building these cars that are only in their fleet. They're not trying to sell these. Do you want to spend a little bit of time talking about the differences between their different sensor arrays and then maybe the tech behind the scenes of how they do the sensor fusion?
So these different cars have fundamentally different philosophies around what kind of hardware they want to incorporate. And famously, Elon has been a proponent of saying, look, humans can drive with just two eyes, this like stereo vision system. So let's just equip a car with two cameras. And in theory, that should be enough. Let's not overthink this, right? And in fact, he said, hey, if we add a bunch more cameras and we add a bunch more different, hardware equipment like lidar, like radar, that actually might just add to a bunch of hardware bloat or code bloat that might end up with these systems being confused or not being able to really calibrate or talk to each other effectively. So let's just keep it simple. Let's just have two cameras and we'll go from there. Fundamentally, I feel like Waymo is approaching it from the other perspective where they said, let's just add all of the hardware. It must be safer. So they have, I think, 29 cameras on their old cars. The new version of the cars has a little bit less cameras, but it's still 13 cameras or something like that. They have 6 radars and 5 lidars in these cars. So a ton of hardware. And all of this sits mounted on top of the car, with some of the cameras being scattered around the back and the sides as well. And here, the challenge fundamentally that Waymo has, and Elon, I think, mentioned this correctly, is the fact that with all of these different sensors, you have to figure out a way to fuse their inputs into one to basically join all the different things that it's seeing, effectively seeing, and combine that into one input that you can feed to a model that then determines whether the car should accelerate or brake whether they should steer left or right. So that is the challenge that Waymo has. And that is fundamentally a physics challenge. It is like, how do you take different sensors and fuse them into one? And for this, there's basically three different ways that you can fuse multiple different modalities together. There's this notion of low level fusion, which is basically what has been the gold standard, which is if you have 29 different cameras, 6 radar, 5 lidar, wouldn't it be cool if at each frame, every time that they get an input, we could somehow combine all of these different pixels and all of these different point clouds into one image, into one 3-dimensional construction that we then feed to the model. That is low level fusion at the level of the individual pixels. Then there's notions of mid level fusion, which are rather than combining them at the level of the pixels, let's just feed each of these individual modalities. So each camera, we feed that into a model. Each lidar, we feed that into a model. Each radar, we feed that into a model that all predict something about the world. So we'll end up with 29 predictions from each of the cameras as to whether or not there's a stop sign, 6 predictions from each of the 6 radar as to whether there's a person crossing the road, 5 predictions from each of the lidar as to where the sidewalk ends, right? And each of those predictions will then combine into one aggregate super prediction. This is easier to do in some sense because you don't have to combine all of the things at the get-go. You can feed them into separate models, combine them at that level. But it's in some ways not a very good or scalable solution in the sense that wouldn't it be nice if we have all this information of the world, if we could just condense that into one embedding effectively and pass that one embedding that contains all of the world knowledge into the model. And that way, the single model has access to everything that's going around it and make a prediction using that. That would be a much more theoretically grounded, more robust approach to fusing inputs together, right?
The lack of different modalities kind of hamstrings you. There's no co-learning potential of how these things relate to one another. And then you're also having to build and train 6 different or, N different models, one for each of your modality, instead of just having one big training job that you can dedicate 4 times the amount of petaflops to.
And it's a little messier too, right? Like imagine you have 6 cameras, 2 in front, 2 in the back, 2 on the sides, and each of them are trying to predict whether or not there's a stop sign somewhere. Maybe one of them says, hey, I definitely see a stop sign. The other 5 say, no, I don't really see a stop sign. Do you trust that one camera? Maybe that one camera is in fact the only camera facing in the direction of a stop sign. Or is it maybe a bug? How do you calibrate the system, right? It's a little messy. You have to find some way of combining these different outputs together. It could basically lead to bugs, is what I'm saying, right? And it leads to all this engineering overhead that's kind of annoying to have to maintain. It would just be so much nicer if you could just, like humans do, where we have all these different senses, we have our eyes, our ears, we can touch things, we can feel temperature, but we combine that somehow into one experience of the world. Wouldn't it be cool if a car could effectively do the same thing, right? So that's this mid-level fusion. And then also what people like to do is at a very meta level, a high-level fusion, where what you could also do is you could have these different modalities predicting different things independently, but then you also fuse together their trajectories. Basically, over the course of the last 10 seconds, can you fuse together these different trajectories, how these modalities have been experiencing the world into one sort of meta trajectory, right? So that you kind of fuse in the last 10 seconds, the experience of all these different modalities, can you fuse that into one experience?
Spatio-temporal.
Spatial temporal fusing. Yeah, that's sort of like the highest level of fusion that you could do. That's a challenge that Waymo has. Tesla, because they have a much simpler stack, just 2 cameras, fundamentally it's easier for them, right? The trade-off is you just have less data. So these are these 2 different philosophies, I guess you could say, or ways of approaching this problem, where it's time will tell which one wins. I think there's a lot of Tesla stands that have bought into Elon's vision of saying, let's keep it simple, stupid, right? Let's just make it easy. Don't overthink this, guys. But the fact that Waymo has been so successful and that the experience is so magical, I, as a user, kind of feel like, hey, maybe you do need these 29 cameras, 6 radars, and 5 lidars to make this experience as superhuman as it is, right?
Yeah. I certainly wouldn't write off the approach out of hand.
No, exactly.
Based on how well they've done. I mean, one technical question on this, Richard. I feel like it's probably pretty unintuitive, at least in my mind, that low-level fusion is so difficult because we have multimodal models that can take in a whole range of inputs in other domains, right? Like we have robotics models, which can take in like different servo motors and text and video and audio. Why is combining LiDAR's images and radar data like so technically hard? Is that a modeling challenge? Is it a train time consideration? We just don't have enough data for Is it an inference time challenge? We just can't do this fast enough. Like, where is the actual challenge if that is the ideal case that we all kind of agree theoretically would be the best and we just can't pull it off?
The challenge is that it has to happen super fast if you want to do this at the lowest level. Think about it this way, right? A camera is capturing frames at the rate of maybe like 60 frames per second or something like that, maybe 30 frames per second, right? That's like roughly one frame every, call it 30 to 15 milliseconds or so, in that range. LiDAR, I'm not sure, but I think also on that time scale. So every, call it 15 to 30 milliseconds, there's a new piece of information coming from all of these different sensors, right? If you wanted to fuse them at the lowest level, the fusion has to happen at the level of, 10 milliseconds roughly, super fast, right? It's hard to pass all that data into a computer, get it to stitch together these different modalities and output one output and do that 60 times per second, right? That is lightning fast inference. That is super hard to do. The other thing is that we're operating at different dimensions, right? Obviously, a camera is recording things in 2D. It's projecting the three-dimensional world into a 2D frame. The point cloud that comes out of a LiDAR is literally in 3D. It's this three-dimensional object. So if you're trying to combine something that's in 2D, the output of a camera, with something that's in 3D, how the hell do you do that? It's not trivial, right? There are algorithms recently that have actually showed that you can combine multiple different cameras and sort of project them into a third dimension via an algorithm known as, I think it's BVE or something like this.
BEV, bird's eye view.
Oh, bird's eye view. Yeah, exactly. So,
Yeah,
so
yeah.
the idea is, you take these different images that are all taken from the same point of view, just facing in different directions, and you can try to reconstruct a bird's eye view using those different cameras. So once you have this three-dimensional projection from these different cameras, then we're talking about, okay, you can take that three-dimensional projection and combine that with the three-dimensional LiDAR projection, right? But again, the challenge is, even if you do that, this has to happen super fast. This has to happen 60 times per second, right? Every 15 to 20 milliseconds, you have to do this projection into three dimensions of all these different cameras and then somehow add that with the LiDAR. It's just super hard to do. And this has fundamentally been an impossibility until we got really performant on-device chips like the A100s, the H200s. So it's only because of these recent GPUs that we're maybe able to do this in some capacity. I don't think that we're able to do this at the rate of, 30 to 60 frames per second, but maybe we can do this twice or three times per second. I'm just pulling this out of my butt, right? I don't really know what the correct figures are, but you can imagine that we're starting to approximate this world where you can actually do this. At some point in the future, you can imagine that this will actually be something we can do at the rate of 30 to 60 times a second. Currently, I don't think we can do this, but that's the challenge that Waymo has, and that's why it's hard to do this fusion. Yeah,
I
it's
think
tricky.
the other challenge is this is still a pretty open research area. Like, I think only within the last few years did this BEV approach really take off, because it makes sense. Like, most of the decisions you can make about what a car should do, you can do based upon just knowing where things are in space and what those things are. So like a bird's eye view of those different objects, maybe combined with some semantic embedding of each thing so that you can know, okay, from a POV looking at a stop, this is obviously a stop sign, but the second that you tilt the axis to another dimension and kind of see it from like a bird's eye view, maybe it becomes a little bit harder. It's still such an open research area of how do we actually build models that can do this well? Because the models themselves are parameterized. It's usually not an algorithmic projection. It's some learned behavior of some architecture to do. I can almost imagine that once we converge on, okay, we have a really good model which can do this, Transformer, CNN, what have you, I could almost see this as actually a perfect case of getting a custom chipset design just to do this, because it's such a rote task that we're just doing over and over and over and over again. And we only care about the output of this pipeline in order to do the perception inference on it. I wonder if maybe that is where these cars increasingly go, where they'll mostly have a GPU for things that need to update rapidly and change over time as the models evolve, which is always going to be true for the actual perception algorithms. If we can really crack the code on this feature level fusion, I almost wonder if that's just going to become an assumed pre-processing pipeline, kind of like BPE is in text processing. It's just like, well, everyone's using NVIDIA's model for BEV. That just is the industry standard.
Yeah,
All right,
interesting.
now the models built on top of it can actually operate at 60 frames a second because the pre-processing sensor fusion, which is so compute intensive, has actually been rendered like pretty trivial.
It's almost like tokenization at the level of a 3D mesh of the world. How do you like discretize the world and fully encapsulate everything that's going around it in a condensed snapshot of the world? That's kind of like the equivalent of what tokenization is for speech, right? It's just a much more complicated version of that.
Yeah, yeah. Maybe the embeddings are much larger to be able to model the state of the world. People are starting to explore models that actually are trained in more of an autoaggressive fashion, right? Because like
Yeah,
instead of doing sequence prediction of each token as a word, it kind of is true that the progress of a robot in physical space is the same autoregressive logic. It's just you're taking time as your x-axis instead of tokens.
Yeah, talk to me about these vision language action models, these VLAs, because I've seen some research come out of Waymo that's trying to do a more, I guess, transformer based end to end sort of modeling of this problem.
Yeah, so conventionally, and I think what Waymo has been doing, we don't know if these end-to-end models are actually deployed in their cars yet, but it's usually kind of been two different research areas. One has been actually doing the perception of what's around you. I'm going to perceive the world around me. And then there is all the logic that you have to take in order to respond to that of what's happening around you. And that's the prediction, right? So it's like perception kind of pipeline into prediction. With the thinking basically that if you have this stoplight, you have this crosswalk, you have these humans, you can kind of imagine that those are different things that we ourselves are doing. We're kind of like trying to just understand what's happening and then be like, okay, time to be a little bit more cautious. I see someone with hazards on. Let me like slow down, brake, figure things out, go around in sequence, right? One of the things about prediction is that you also can combine different approaches. You can both have the modeling and you can have a parameterized model making some call about what to do. And you can also have some deterministic rules about how do we want to codify the rules of the road in a way that doesn't require us to train and label and bootstrap a lot of this data. So we've had both. These end-to-end models basically are operating with if we can just compress all of the world representation that we measure from these different sensors into these tokens, that we can then combine them with other things like thinking models, text processing, which is what the main one out of Waymo, Emma, does internally, right? So it's kind of this reasoning model, which actually sketches out in text tokens how it's considering the situation, what it's perceiving. It has some text prompts that are part of the pipeline as well for like describe if there are any people in the scene, where they are, where they're located. And then the end output that you actually care about is going to be saying, okay, here's the bounding box and the tags of the people that are in this area. And then also, this is what you do: continue speed, slow down, brake, turn left by these many degrees, etc. And I think they're unique, especially when compared with other multimodal models, because the numerical output has to be very specific and
Yeah.
accurate.
Yeah.
It's actually a good experiment to do at home. I think it's pretty easy. If you just upload a photo to ChatGPT or Anthropic and then ask it to give you point-based coordinates for something that's in the photo, it usually does a pretty bad job because even though it's an image model, it's not really aware of what these pixels correspond
Yeah, it
to
doesn't
in
like
numerical
it
space.
doesn't know where things actually are in relation to each other in an actual physical space. It understands like the semantics of what it's being shown, but it doesn't understand how things are laid out exactly, which is kind of hard to think about because for us humans, like those two are almost one and the same, right?
Yeah, totally. So it's, the default models just aren't optimized for that, whereas Emma is. And I think this whole ecosystem, like DeepMind's doing a lot of work on this. They have their like RT2 model. A lot of these are fine-tuned base models. I think Emma is actually a derivation of Gemini that they were using internally.
It's so interesting to me because we don't, at least I don't work in the vision space. The state of the art models I'm usually not fully aware of as they're coming out. But it does seem like in the domain of language, we tend to use Quen or Kimi as base models. Pali and Lava tend to be the equivalent in the world of vision. And so I think Emma is also a derivative of one of those.
Yeah, I mean, super interesting. Do you think that there is a non-trivial benefit to the co-training that is implicit within these models? I mean, they definitely feel more steerable to me. If you want them to change behavior, you can potentially just put that into a prompt, which then opens up the same kind of opportunities for improving these models just via prompt. So like almost post fine-tuning, query tuning time seems like it gives us more of an ability to do that with these action models. I can imagine that there are also probably some co-learning elements of just the more modalities that you throw at the same thing, we show that they're usually positive. They interact in a net beneficial way. But do you think that we're going to keep this segmentation between perception and prediction, or that they've seen enough promise in things like Emma for this to be the default thing going forward? Just like we see with a consolidation in most other areas of deep learning, where the more end to end you're able to make your training pipeline, the better the results you're going to see.
Yeah, I think that end to end is always the right solution. There are a couple of very specific use cases where that's not the case, but I think especially for, interactions with the physical world, having perception and prediction be effectively the same model makes a ton of sense. It's almost hard for us to imagine a world in which our brains are compartmentalized in this way where we perceive something, but we can't predict what's about to happen. If you perceive a chair falling over, at the same time, you have this module in your brain that knows, oh, it's going to hit the floor in the next half a second, right? It feels like it's almost fundamental to understanding the world that you can both perceive and predict simultaneously, right? And you can kind of plan your trajectories in this world because of how you perceive the world. So an end-to-end solution makes sense. It is telling to me that even though Emma was published by Waymo, they clearly don't use it for their models. This is like an idea that they're testing
Prototype.
out.
Yeah.
Because Emma doesn't actually use lidar or radar. This is purely a video-based, a picture-based model. It's not fully end-to-end solution in the sense that you can't plug it in with your full array of inputs and get one output yet. That is, I think, the holy grail here. That is something that would be really interesting to see. And again, I think fundamentally the problem that these companies will have to tackle is this fusion problem. How do you fuse these different modalities together? But not just that, how do you do that very quickly? That is almost the crux that everything hinges on. Once you can do that, and once you can compress everything into one really clean embedding, then the actual model that you use to process that doesn't have to be that complicated. It's almost like the fusion of everything into one clean vector. That is the hard part because that vector has to compress all of your world knowledge.
Yeah.
And intrinsic in that is already basically like an understanding of what the world is, like what's happening in the world and how to interact with the world.
I mean, talk about a world model. It almost has to be that one of the smallest parts of the model by like vector volume, which is the input at each time series, has to be able to capture such a variety of inputs in as close to a lossless way as possible.
100%. And I think it's actually telling if you go on Waymo/research, Waymo is actually very prolific. They publish a lot and you can see all of their papers that they're working on. The last maybe 10 papers or so, if you go on their website, they're all simulator papers. So all of these papers are basically like, hey, we trained a diffusion model to build a world simulator. Hey, we trained a transformer to simulate traffic lights. We trained a transformer model to simulate pedestrian traffic, blah, 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 right? What they're clearly trying to do here is they're trying to get into the business of building world models. It seems like everyone is trying to do this. Jan LeCun is trying to do this. Feifei's doing this. Everyone loves world models. But it makes sense, right? Because if you can build a world model almost like a city simulator where you have traffic lights, you have pedestrians, you have cars, and you perfectly simulate how these cars interact with each other, how they interact with traffic lights, how they interact with stop signs, how they deal with potholes, how they deal with when a human crosses the road, when they jaywalk, right? You've basically solved 90%. You're 90% of the way towards actually building a driving policy for how to interact with the world. If you can simulate the world, then you know what the right thing to do is in the simulated world. It's almost like the simulator is the hard part, being able to actually understand how the world works, how physics works, how cars interact with each other. That, once you can condense that into one representation, how to then act in that world becomes trivial because you understand the world.
Well, you can also just throw RL training at that environment.
Exactly.
You know what I mean? Like,
Exactly.
if you want to kind of separate out the tasks, because that is almost by definitionally true in my mind. Once you crack the code of how do you do almost the generation task of all of this, you've almost had to solve the question of how does one drive? How does one interact with the space by virtue of having a world model? For a while, people were building these manually in video game engines. You know, like people were using Unreal to try to come up with the best physical simulation of a city as possible, and then launch RL agents and computer vision models to synthesize data. That was like a really big market maybe 2 years ago. A lot of companies were getting started and getting funded based on that idea. I think the problem is that that's going to be fundamentally limited by the creativity of the game designers or like the engine designers to be able to say, these are the things we think are going to transpire in a city. Like almost the act of creating a useful world model is having a world model that can generalize enough to totally unseen or unconsidered situations and still have that be semantically reasonable in practice.
Exactly.
You know what I mean? If you prompt like, hey, I think we need some data on how people jaywalk or like what people look like if they're jaywalking. You know, if someone is doing a back bend and then jaywalking across the street, we should still stop the car. But I guarantee
there's just some
not,
marching band that just walks across,
yeah,
right? It's like you have to learn how to deal with that.
If there are a bunch of penguins crossing the street, you know, we probably still want to stop. It's like a good world model should be able to do that, even if a video game designer never would have even considered it.
I think you'd be surprised at how many outlier events occur every single day as you're interacting with the world. It's one of these things where maybe something has like a 1 in a million chance of happening, but there's 7 billion people on Earth, right? So there's just all this really weird stuff happening all the time and you have to learn how to deal with it. For instance, the other day, they had this construction next to the parking lot where I parked my car. So they'd set up a traffic light and it was like a temporary traffic light, right, that they'd set up and it was red. So I stop and 30 seconds go by, a minute goes by, it's not turning green, right? So at some point I'm playing this game theory of, okay, is it broken? Is it not broken, right? And so I'm thinking, okay, well, clearly I see that the other people over there are also waiting. Okay, well, after, 20 seconds, it just wouldn't make sense for both of these lights to be red. So it must be broken. So then it's like navigating the social dynamics of, okay, well, it's a game of chicken, right? I have to either be more aggressive so that the people know that, do they know that I know that their light is broken, right? And so I have to then assert myself. It was like a whole thing, right? I ended up just like aggressively like pushing on through, and then it was like clear that the other people then had to wait, right? And that was almost
or
like
using the human cues of literally looking at them, trying to make some hand motion, acknowledgement, and then signaling who should go. I sometimes do that at 4-way stops. You know,
yeah,
but
in this case they were just far enough. They were maybe like 500 yards away that it would be hard to do that. You know what I mean? So it's one of these situations where it's almost safer to do the aggressive thing so that you clearly communicate what you're about to do to the other party. I mean, point here is basically that how do you like learn that policy in a Waymo or in like a simulated environment, right? You need to basically be able to simulate all these crazy, weird outliers. Otherwise, within a week, the Waymo is going to encounter a situation that it's never seen before, right? You have to really learn fundamentally like how humans interact with each other, what kind of stuff can happen. If something weird happens, how do you resolve the issue? How do you problem solve, right? What is your process for solving an unsolvable problem that you've never seen before? How do you even begin to tackle it? All these things you can only do if you have a good world model or a good understanding of how the world functions. It's a hard problem, man. And I'm like really surprised that the tech is as advanced as it is. Can we maybe talk briefly about why this highway driving thing is so exciting? It feels like Waymo's been around for a while, but now people are again excited about Waymos because all of a sudden they can go on highways. What makes highway driving so special? What do you think?
I mean, I feel like the risk of something going wrong is just so much higher. It's interesting and maybe emblematic that Tesla and Waymo have gone at this from two different directions, where Waymo started just on residential roads, kind of like under 35 miles an hour. And Tesla started on the freeways, right? Because Tesla, you have a built-in assumption that there's going to be someone behind the steering wheel. And in fact, they force people to be attentive and alert by keeping their hands on the steering wheel, or at least close by, like every 5 seconds touching the steering wheel, so that they can take
like
over
buzzes or something,
if
right?
something goes wrong, right? Waymo, from the start, they said, we want to make a fully self-driving car. And I think in that kind of a setting, when humans aren't going to be able to take over, the risk of something going wrong just comes into play way more, right? If something goes wrong, braking at 25 miles an hour is not going to probably hurt the passenger and probably not going to cause that severe of a collision behind you or in front of you. Braking at 65 miles an hour in a highway traffic flow is going to cause way more problems. And I think you see this, right? Like the crashes that Teslas have had on freeways have been catastrophic. Like people were injured, people were killed when the car was
It's
otherwise
also,
in self-driving mode, just because you're going so fast.
the braking distance is quadratic, I'm pretty sure. I'm pretty sure that's how the physics works
Yeah.
out. So if you're going 4 times faster, it takes 16 times longer to brake.
Well, yeah, I mean, it makes sense.
that's
The
just-
kinetic
that's the
energy
physics
is,
of it.
yeah,
Exactly.
or like the momentum that you end up getting is quadratic.
Right.
So, yeah, so it just becomes way more dangerous to operate. The irony is it's an easier task when you're on a freeway because you have very well demarcated lanes. There are no stops. You're really only going straight, maybe making like very subtle curves. One of the biggest challenges that they actually had to solve for in Waymo and then in the new version of self-driving at Teslas is the threshold at which the control system was able to turn the steering wheel. Because when you're on residential roads, I'm sure you've gone up these like windy roads going up Mount Tam or in Palo Alto or whatever. I feel like
Yeah.
London's a little bit
Yeah.
straighter. But around here, it's all over the place. You're doing these like windy switchbacks up mountains. And it seems obvious because when a human's driving, yeah, we'll feel comfortable tilting the steering wheel 2 times if we have to turn the wheels that much. But if you think about when you're actually developing a deterministic control system, if your model is giving you back a prediction that says, hey, Richard, I know you're going at 25 miles an hour. You need to jerk the steering wheel 45 degrees from where it just was. You'd be like, oh, that's way too suspect. We're not going to do that.
Mhm.
That'd be insane. So the original control systems of the Teslas, I was driving with Cam one time in LA and he had it on. It was doing well and then struggled to get up these switchbacks because it was like the car was trying to torque the steering wheel maybe 30 degrees, but it had to do a proper 45. It just wasn't allowing itself to actually get that aggressive. And I think that that's kind of the situation is like Waymo has not felt like they had the confidence in their driving abilities to be able to navigate all of the nuances of highway driving. And if something did go wrong, it would have gone wrong in a serious way.
It would be
Yeah,
catastrophic.
it would have been catastrophic.
Yeah.
Now I
Yeah.
think
Yeah.
they
Yeah.
have the miles under their belt in order to feel more confident. Interestingly, though, I drive freeways in the Bay Area a lot, mostly up north, but like a decent amount commuting down to Palo Alto. And you don't actually see that many Waymos driving on the freeway, even with human supervision. So I think it's interesting how they were able to bootstrap enough data of highway driving for them to now feel comfortable at letting these things go fully autonomously. And that probably just brings us back to the world models. I wouldn't be surprised if they have in simulation run millions of hours of Waymo highway drives and, let the law of large numbers take care of trying to find the nuances.
Yeah, I mean, a highway in some sense is like the easiest road to drive on because you just go straight and then you get off at some point, right? If you have a very conservative policy, you never have to switch lanes technically. Once you get on the lane, you just kind of keep going forward. If the guy in front of you brakes, you brake, and then otherwise you accelerate to your desired speed. In that sense, highway driving is actually probably safer almost, or an easier policy to learn. But I think what you said is totally true. I mean, I think a lot of this has to do with we have to be 99.999% sure that these models are working. Because if there's an accident at 70 miles an hour, you're going to die. That is pretty scary.
Yeah.
And I think Cruise actually is in part of the reason that they're not in business anymore is because they had a massive lawsuit. I believe that there was an accident. They got sued. Tesla obviously now has a $300 million lawsuit for, I think they killed someone or there was like a bad injury with one of the self-driving modes. So it's, it's a real liability for Waymo.
Yeah, I mean, I think one benefit of the highway driving is also it's just like way more maneuverable within the Bay Area. I mean, up until this week, I guess, when it's going to start being rolled out on highways, you could definitely do in San Francisco or in Redwood City or in Mountain View, but just the way that the Bay Area is segmented, it's kind of impossible to get from city to city unless you go on 101, or at least it's like unbelievably
Right.
impractical. You're cruising down Camino Alto the entire way. I still feel like even with the Bay Area, the regional zones are now like San Francisco, LA, Austin, Phoenix are like the four. There might be a fifth that it
Mhm.
operates in as well. But I mean, do you think that there is something either limiting about that strategy or that speaks to some of the underlying technical limitations where Waymo has to pre-map out each city that they go to before they let their cars run wild within that city? Or that's more of a business policy decision to try to optimize where they're having to expend all this CapEx?
Yeah, I mean, it's a business thing, I think, you know? Most people live in cities, so why not just get these cars to work in cities? I don't really know why I would ever wanna take a Waymo to Yosemite. What's the point, you know? I'd be scared that there wouldn't be a Waymo to pick me up. It doesn't really make any sense. If I'm gonna do that, I'm just gonna rent a car. So what's really the use case of having these cars operate in the deep suburbs? It doesn't really make any sense. I mean, from a business perspective, it's exactly what I would do too. It makes a ton of sense. No, actually, I think that transitions us nicely into talking about whether this thing is even profitable to begin with, because I mean, I don't wanna steal your thunder here, but, I think the answer is no. What do you think?
Yeah, I mean, at least not as it's currently laid out right now. I mean, Waymo has an unbelievable loss every year. I think it's 1.5 billion as of at least the last reporting cycle. They make maybe 125 million in revenue. I think that there are a few things going on, right? I think most of how that breaks down is in the R&D of actually training the models, right? I think if you were able to somewhat segment out their consumer ride hailing division to say, you're just licensing software from some other Waymo body, then that would be profitable relatively quickly. But because you have the company doing everything, and that's an included number, I mean, they're absolutely lighting money on fire. They also incidentally have some of the biggest GPU clusters around. I don't think a lot of people, when we're talking about LLM buildouts, really think of Waymo as one of these institutions that has a ton of compute at its disposal, but they do. I mean, they use them for all the simulations, they use them for all the world models, they use them for all of this different modality training. There's so much compute that's going into this. I think that that's their main cost. It's like staff salaries, it's data labeling, it's data acquisition, and it's model training constitutes a very large loss. And then they also have to build out these cars. And each car as well, right now, it's a custom build effectively. I mean, they don't have a huge manufacturing line that's pumping these things out in mass.
Well, I think they are creating a manufacturing line somewhere. I was reading about this.
Yeah, this is their like new generation of car architecture. I think it's like the
That's
Waymo
right. Yeah.
7s, maybe. They've had like different iterations of the underlying build.
Yeah.
This, interestingly, they piloted these for a long time. The first announcement about this co-manufacturing is with this company in China to build the underlying, car mobility platform, and then Waymo would stick their sensors on it. Was years ago. I want to say in like 2020 they did this announcement for the first time. They've been testing them ever since. I think they were finally getting ready to roll them out more publicly, and then the US had all of these tariffs placed on Chinese imports. So it made the cost competitiveness of these cars a lot lower than they otherwise would have been. Just interesting.
That
Geopolitics.
is interesting. Here's the rosier picture. So I dug up some weekly rider statistics. When they first came out 2 years ago, they had 10,000 weekly rides, which I guess that's good. I mean, it's kind of hard to put that in perspective, right? But 2 years later, they're now at 250,000 weekly rides. So, I mean, we're talking like 30,000 rides a day on Waymos. And that number is probably as of November 2025, because I think that 250,000 is in April.
Mm.
We're probably approaching 500,000 weekly trips at this point. And here's the thing, it's hard to put that number in perspective if you don't know how many weekly rides Uber has. Do you know how many Uber has across the whole world?
20 million rides.
It's an order of magnitude higher. So there are 200 million rides per week, and Waymo is at 500,000. So there is, if I'm doing the math right, there's about 400x that they could still grow from here. So now we're talking about on the order of like $40 billion in revenue if they could pull this off. All of a sudden, it makes sense why they're valued currently at $45 billion, right? If the market cap is really where they could be making 40 billion in revenue. And obviously, unlike Uber, there is no driver, right? That would basically already cut about 60% of the cost that Uber has. So the revenue would be even higher. So people are fairly optimistic, I would say, about the outlook of this market as a whole. I think JP Morgan says that they're estimating that Waymo could be making on the order of over $1 billion in revenue in the next year and a half. Who knows if that's true? But I think you could make the Steelman argument here that there's a lot of money to be made. If someone's going to make that money, it's going to be Waymo. And from our own personal experiences, if you've ever been in a Waymo, if it's at the same price point as an Uber, hey, I'm picking Waymo every single time, right? So who knows?
Yeah.
Right. I wouldn't bet against Waymo at this point.
User satisfaction is very high. And I think a lot of things flow from that. Like that gives you pricing power if the good is desirable that people want. I think also structurally, you're literally accounting for these business things differently. Like in the Uber case, there's a marginal cost to each ride for you as a business because you have to pay out for the person who's actually driving the car. And then that, I think they're still mostly independent contractors. They actually take care of the gas and the maintenance and whatever. So that saves Uber from having to pay for it. But you're right, like that 60% of each fare is basically going to distribute to that person. It also, used to be higher. So Uber's trying to claw back as much of that money as possible. But there's a point at which it just doesn't make sense for the people that are driving these rides. Waymo is much more of a business model that I think companies like. It's a little bit more SaaS software in nature, where you might be spending a lot of money on the technical R&D to build the software platform. But if the marginal cost of each additional ride is basically zero, just like the marginal cost of each additional software seat is usually literally zero, then you're building a business model in which the larger you get, the better economies of scale you have. Whereas Uber, that's not really true. Like you kind of have to discount the 60% haircut across the board. Whereas Waymos, if you have that centralized R&D, even if that costs $2 billion a year for the compute, like I think you're kind of making it up by this last mile thing of having the physical infrastructure in place. So we'll see. I wouldn't bet against them either.
Yeah, I crunched the numbers. I was kind of curious to see how long it would take for a Waymo to pay itself off in terms of the cost of the actual vehicle. So if you do the math, you can look up how much an F-Pace costs. So a Jaguar, a new F-Pace is like $60,000, $65,000. If you look up the cost of the lidar arrays, yada yada, it probably come out to like $30,000 in additional. Let's call it $100,000 in total for this car with the lidar arrays, right? It would take roughly, assuming that the car can do like 40, 50 rides a day, about 9 months for the car to pay itself off. And so then you can imagine that anything after 9 months, the car is basically just making a ton of money on, right? Because the cost for the electricity it's not zero, but it's maybe $1 or so, right? And then the remaining, let's call it, if it's a $20 fare, 19 of those dollars just flow back to Waymo. And that's huge, right? That is a dream. So if you can get this car to really last 5, maybe 10 years, that is tremendous for Waymo. I mean, at that point, they're making up the cost of the car 10 or 20 fold. So it's one of these things where time will tell if this is a winning strategy. I think these F-Pace cars are super nice. I could see them lasting 5, 10 years easily, but who knows? I wouldn't bet against Waymo. I would love to be able to invest in their company,
Well, you can if you work there.
It's true.
I mean, that's kind of the unlock implicitly. I mean, that's really putting your money where your mouth is. That's making one bet. That's putting all your eggs in one basket. But yeah, I mean, listen, they don't have any driver acquisition costs. That's a huge expense for Uber and Lyft because people just churn so quickly. They join the marketplace and then they leave. Same thing with customers. They're always in this competition with Lyft. Like Waymo is pretty well poised. I think the biggest competition for Waymo will probably remain private car ownership because people in the city that use it usually don't own cars, right? The people that I know that do own cars in the city are usually not using Uber or Lyft or Waymo with any kind of frequency. So, I mean, when you move out, this is actually probably top of mind for you because you have to make this call.
Yeah.
When you move back
100%.
to the city, you think you'll buy another car? Or you think that the existence of Waymo, at least within the city, kind of ruins the idea of private car ownership?
Let's put it this way. If you were to ask me that in Europe, I would say that I might actually just get like a a Vespa and then have access to a Waymo. And the reason I say that is because in Europe, the cost of car ownership is exceedingly high, right? Like insurance is very expensive. And here in Europe, we just really tax gas, right? So getting a full tank of gas is like maybe $100, a little bit over $100 to fill up your car, maybe $110, $120, just a normal car. At that point, you're really kicking yourself every time you have to go to the gas station, and parking's expensive. Everything is expensive. So at that point, if a Waymo is like $10 and you do it every so often, yeah, that makes sense. And then you got your Vespa to go to the local store, get a baguette, go to
And
the
you look
farmer's
so
market,
cool while doing it.
and you look awesome, right? In the US, it's tricky, man, because we just don't live in a world where access to, to a car is instantaneous yet, just because, the fleet of Waymos, there's about, I think, 1,000 Waymos, I want to say, in their total fleet. There's a lot of them, but there just isn't enough for it to feel like you can always get one or you could always go anywhere. But if we were to live in a world where even if I'm in Yosemite, I call a Waymo and it gets there in 5 minutes, at
Now we're
that point,
talking.
that's a real paradigm shifter, Once it really feels like you're never stranded, you can always get access to a Waymo. That is a real game changer. And that is something that I would say, yeah, I don't need a car at that point anymore. But that might take another like decade or so. I don't know. What do you think?
Yeah, I mean, I wonder, right? I think we talked about why the Waymo business model is good. I think one reason why it's bad is because you need centralized facilities to manage the fleet of cars. At least in order to make it economically feasible, you need one repair center or one cleaning facility. I think in San Francisco, that one's located in Dogpatch. Lise had to go one time to pick up my phone that I left in a
From a Waymo?
because I
geez.
couldn't get there without my phone. So it was kind of a recursive problem where I knew where it was, but I couldn't.
Wait, but how did you tell Lise that your phone was in the Waymo?
Oh, I sent her an
phone?
iMessage on my computer.
Oh,
But you can't
okay.
call an Uber on a computer.
Huh.
So I couldn't get there. I also couldn't rent a Lime bike. I couldn't do anything. I felt so stranded. So anyway,
I love the concept that like calling a cab. You know what I
no,
mean?
what?
Is like,
Excuse me, call a what?
you're never gonna do that though. You know,
I don't even know what that is.
I just love that you're like, I just don't know what to do, man.
My hands are tied. Hey, Lise, can you please?
My hands are totally tied. There's
Please
no
get
solution.
my phone. So anyway, there's this centralized facility. She was like, it was crazy. It's like where they
Right.
tuck in all the Waymos to sleep at night,
Oh,
it's just this
wow.
place in like Dogpatch, Bayview. So anyway, there's like
Fascinating.
one centralized facility that I think manages all of San Francisco. All of the Waymos, go home, get plugged in, go to sleep, and this place in Dogpatch. If there's a Yosemite Waymo, I mean, where does it go? Like ostensibly when humans are doing it, if you wanted to pay enough money to get an Uber driver to take you to Yosemite, there's probably some guy who would. And if they have to get gas on the way back, that's fine because they'll just pull over and do a gas station.
Yeah.
I think for like
Yeah.
long haul trips, it's just harder to conceptualize how Waymos fit into any existing ecosystem, including like EV charging ecosystems, because they all require the assumption that there is a human to operate these things to be able to insert.
actually put it
Yeah.
in. Yeah. Well, that
So-
I
so-
feel
so
like that's one of these last mile things that can be solved.
at some point with enough scale, like totally, right? I guess what I'm thinking though is if the bulk of the market internationally is located in cities, and then there is just this long tail of people that
Yeah.
signed up for Uber in more rural areas because they could and it's free and they might get some rides occasionally. Maybe there's 2 Uber drivers in a small town, like that could actually be a relatively good income stream for you. I wonder if we're ever really going to reach the point where people feel fully comfortable to not have their own car because people, at least stateside, want to make these drives so often, like want to see the country in a way that I think mostly because Europe just has better train infrastructure, you don't really need in the same kind of way. Like urban density to
Yeah.
me has such a tight correlation with, is this even feasible? I think even in 10 years, I question whether or not these are going to be really ubiquitous or if it's going to be more like you won't own a car. You'll use a Waymo when you're traveling around in cities. And then there are a ton of, Hertz rental car centers or like Zip cars where you end up being able to rent something on the cheap to be able to go outside the cities.
Yeah. Or there's obviously this vision that your car, when you're not using it, could become a Waymo, right? or maybe you own a Waymo, you drive it yourself, or you let yourself be driven by your Waymo. Then when you park it, it just kind of does its own like little Waymo thing, and you make money passively, right? Like you're the one who buys the hardware, and then it makes a passive income stream for you when you're not using it. Who knows? That'd be really cool. I've always liked that idea. Time will tell, man.
Time will
I
tell,
think this
man.
stuff is so cool.
Yeah, me too.
I love these applications of really cool modeling to physical hardware when you can actually physically experience something. I think that that is such a magical experience. And yeah, I mean, it's such an unlock. I think Waymo is so cool. And I can't wait for it to come to Europe. I guess at that point I'll be in the States again. But I don't know if you heard, but it's coming to London, I think, next year.
Really?
They're going to be,
Oh,
yeah,
wow.
yeah. I wonder if the steering wheel is going to be on the other side.
Yeah.
If they're just going to like import the American cars, you know?
Can you drive American cars in the UK?
Yeah.
Okay.
There's nothing technically illegal about it. You can have the steering wheel anywhere, I think. You could have it in the middle if you wanted to.
As long as you remember to stay on the right side of the road.
Yeah, there's a McLaren. I think the McLaren Speedtail actually has the steering wheel right in the middle.
Huh.
And there's a passenger seat to the left and the right. It's like one row of three.
So you can
and the
cuddle
driver
with
sits
both
in
of
the
your
middle.
buddies.
You should look up this car, dude. Look up McLaren Speedtail. It's actually objectively one of the coolest cars.
Put it in
out
the
there.
garage. Yeah, no, I'll take a look later.
Oh, yeah, duh.
Yeah,
Sorry, I
yeah, of
forgot.
course.
Of course,
course.
dude. Of course. All right, boss. Well, this is a blast.
Speaking of cars, yeah, maybe you do know something about cars. I know something about Waymos. That's it. Wow, this car looks crazy. This car looks crazy.
Doesn't it look so cool?
Wow.
Anyway, maybe we'll throw it in the show notes.
Yeah.
Well, thanks for listening as always, and I'll catch you on the flip side, Pierce.
Yeah. Till next week, Rich. This was fun.
All right. Till next
Gotta
week.
catch my Waymo.
Bye.
Bye.
Yeah. See ya. Do you think this will look bad in the future?
This podcast,
Yeah, like 4K.
it feels like it can't because
It looks so good, right?
it looks
But-
it looks so good,
Right.
and you literally have now gotten pixels so close together that it's imperceptible to the human eye.
Right.
Doesn't that, by definition, kind of mean that this is as good as it can get?
I mean, maybe the medium will just look old, you know?
Yeah, like us being like flat. I want to be able to sit down at the table with them.
Yeah.
Hello to all our future viewers from the year 2045.
Yeah, exactly.
My Bugatti is actually parked in my garage. So you're going to
That's
have
right.
to go
You're gonna
out
have to take
my
my word
door,
for it, man.
take
Yeah,
a
yeah,
left,
yeah.
open the garage.
That's right. That's
The combo is 8912
That's
pound.
right.